Okay, let me actually repeat this. So the schedule on the syllabus is not really accurate because due to the delay of the schedule, you know, it's mostly because of the snow and the sun of the holidays. Uh, so we have probably 1 or 2 weeks delay. Um, so the test will be scheduled after we finish the chapter 7, the objects and the classes. Um, but just keep that in mind that I will at least give you 1 week, uh, you know, before the test. So I will announce the test just 1 week before the actual test time. So if I don't announce anything, um, even though the syllabus says, oh, we have a test say April 2nd or April whatever. So it's not accurate. So you have to actually keep actually looking at the class schedule. Okay, so yeah, class chapter 7 is a big chapter. So we talk about the classes, we talk about the objects, and we also mentioned that um, we can create many different objects for a class, and also we mentioned that the class a class is an object. A class actually when we declare something as a class, and it's a reference. You know, um, so a class variable is a reference variable, which means that when you declare a particular variable as a particular class type, then that variable is a reference variable. Basically, it means the value for this variable reference for this variable reference variable for this object reference. I'm sorry, for this reference variable is actually the memory address. This memory address actually eventually point to the object of this class type. Okay, so we actually talk about this primitive type and reference types in I think not just one time, 2 times in a class. Just keep that in mind. The major difference between primitive type and the reference type is that if we do the assignment, the primitive type is actually will copy the data to the new variable, but the reference type, like a class, for example, like a string, which is also defined is an object. So when you actually define two reference variables, x and y, when I say x equals y, it's not, it's just assign the reference of y to the reference of x. It's just copy the reference of y to the reference of x. So that means once we actually execute x equals y, then that means both x and y are going to point to the same object because you copy the reference of y to x. Okay, let me actually repeat this again. If I say, if both x and y are reference variable, and if I say x equals y, that means I copy the reference value of y to the reference of x. So that means both x and y has the same reference, which means both x and y will point to the same object. Okay. So we use the example of bank account. Um, so now today we're going to continue to talk about some of the you know terminologies, keywords, and some of the operations for the uh, object. Uh, so an object member methods is called using syntax object dot reference dot method, right? So that's something. Now for example, we say bank account. That's a class we declared. And if my account is a bank account, so I declare my account is a variable, which is actually of bank account type. So then my account is a reference variable. Okay. So then if it's a reference variable, we have to, for the class definition, we have to call the constructor, right? So depend on the different constructors we use. The default constructor is the constructor that without parameters. So we don't need to provide argument for the default bank account. But if we use the bank account, another constructor says bank account, and then we provide the dollar amount in the first argument, and we provide the name of the account owner, then that's another constructor, right? So remember in the example, we created 3 different constructors. Now, suppose I use the default constructor. So that means the initial balance was 0 for my account. And what's the account owner if I use the default account? Remember that in the example? The default account owner was, if we use the default constructor, the account owner is, come on, does everyone know that? It's John Doe, right? So please actually check the code I just posted on the Blackboard. Okay. So once you declared my account as a reference variable of bank account type, then I can use all the bank account methods, the member methods. So this is how we're going to use the method. So once you have a reference object reference, my account, and then if I want to deposit something, then I can say deposit, right? And then I need to provide the dollar amount, 500. Okay. Then I call the method to deposit $500 to my account. Now, since the account owner is John Doe, so we can say set so we can provide my own account. My account, I say Brady. Sure. Okay, I just provide the string of my name. And so these deposit set account owner, these are the methods, the member methods provided for the bank account. So I can use the methods by use the object reference, which is my account in this case. Okay. Now, if you declare another account, say my checking account, and then I can call the method by say my checking account dot deposit, my checking account set my account owner, and so you can actually call the method by using the object reference dot method. Okay. So many times in Java, the object reference before the method name is known as implicit parameter of the member method. So this object reference is implicit parameters. So you don't have to know that, but this just it's good to know that because when Java compile it, So in a method, they normally, the compiler gonna actually put this object variable as the first parameter. But when we actually call it, we don't have to, put this one. We actually put this one before the method. You just object reference dot method. But compiler actually treat this object reference as a parameter, and it's also the first parameter. That's what compiler interpret the object variable. So, but when we actually call it, we don't have to mention that. That's why it's called the implicit parameter. So, just good to know that. Okay. Now, in the member method, the implicitly passed object reference is accessible via a keyword called this. Okay. So this is a very interesting keyword. Okay. So when inside this class definition, this basically means this particular actually class. Okay, let's actually take a look at the examples we actually worked on last time. Okay, just hold on. Let me just go over there. Click repel. Oh, that's not the one. So remember the bank account we worked on. We have 3 constructor: bank account string, owner. So we provide 1 parameter, we provide 2 parameters. So if we provide no parameter, then the field variable is actually initialized by the default value. So balance, but default value for the balance is 0, and default account owner is John Doe. Okay, if we don't provide these parameters. And then sometimes people say, well, we should allow people to call this constructor to provide the owner of the account. So then you can provide the owner as a string type, and the owner going to be copied to account owner. And the balance, I assume that if everyone called this constructor, the balance is 0. Okay. And then we allow people to call bank account and provide the initial amount, and the owner provide owner information. So then when people call this constructor, so they're gonna actually create a bank account, and they're gonna actually put the initial balance. It's not necessarily zeros. For initial amount is just the amount you want to deposit into the account, but you don't have to call the deposit, but because using the constructor, you can put the initial amount and assign to the balance. Okay. And then the owner going to be assigned to the account owner. Now in Java, sometimes people allow us to use the keyword this. What does this mean? This means if I use this in the class bank account, this basically means the bank account, that particular class. Okay. So when we actually, say what is the balance is a field variable, and these are all the field variable I use. And sometimes if I want to emphasize this balance is a field variable in the class bank account, in this class bank account, we can use a keyword called this. I said this dot is dot account. That's okay. You can use that one. Okay, sometimes it's really good idea to put this in the field variable. Even if you don't put this, then people still gonna actually check oh, balance, where's balance defined? It's defined here, so it's a field variable. But if I put this, now people don't have to go and look and just say, oh, this dot balance. So that means balance is a field variable. Okay. Now, sometimes if you put the keyword this for most of the field variable, it's gonna cause less confusion. For example, if I want to define the bank account, okay, instruct a constructor called bank account, and if I want to actually provide the initial value for the balance, and then I accidentally put the same name for the parameter. So in this case, so I call the constructor bank account, and I provided my own, define my own parameter. So I want to actually, that's the initial balance I want to actually assign to the balance. But I accidentally put the same name as this. But this dot balance and this balance is different. So now I can just put the balance here. Now, then I know this balance without this, that means it means this parameter I just passed. Okay. And this account owner is the parameter I just passed. However, the balance over here, because I have this dot balance, that means this balance is the field variable balance. And this balance is the parameter I just passed. Okay. Now, this just give you example that in case you have the field variable called balance and the parameter I passed as a balance, and I want to differentiate this, but in reality, don't use this. Don't try to actually use the same name, even though this is actually okay, but this is still cause some confusion to the people, right? So still, I just recommend don't use this. Okay. Still, I recommend you use different one. Okay. Init amount. Don't use the parameter called balance and use the field variable called balance. Don't use this, even though you can use this dot balance to resolve that issue, but it still actually cause confusion. So I still gonna change it back. I don't use the same name. Okay. And also, sometimes you can, when I call the constructor inside the class definition, inside the class bank account, and then I can use this to represent another constructor. For example, I had declared a constructor bank account, double init amount and the string owner, a string called, which is owner, and then I assigned the initial value to the balance. I assigned the initial owner to the balance to the account owner. But when I defined the default, when I define a default constructor, I can actually call another constructor. So I can call the constructor inside another constructor. So let me actually comment this one out. So the default constructor I can use is I can call this constructor. So in the default constructor bank account parenthesis, I don't provide default constructor. In default constructor, I don't provide the parameters, right? However, so I can call the other constructor in the default constructor. So in this case, so so if I want to say I want to call this constructor, say, can I say call bank account? And so, and then initial value is 0, and the owner is John Doe. Can I do this? The answer is yes, but instead of using bank account in here, I use this. Okay. So that means if someone create a variable like in the main method, okay. So if someone create a bank account, say bank account John's account, and I call the default constructor. So when I call the default constructor, so this constructor will be called. Okay. Now in the implementation of the default constructor, I actually call another constructor. So I call the constructor number 3, 1, 2, 3. In this constructor, I provide the initial amount and the initial owner. So I just put the actual value for the initial amount, and the initial owner is John Doe. So I actually assign 0 to the balance and assign John Doe to the account number. So then, so the default account is just to call the other constructor by providing the actual value for the field variable. So the initial amount is passed as 00, and the owner is passed as John Doe. So if I call this, then everyone call the default bank account. The balance is going to be 0. The name owner going to be John Doe. So it's just the same as using these two assignments. Okay. So in this case, I can use this. So this, so you must be careful when you actually when you want to refer the bank account inside the class bank account, you can use this. This basically means this class. Okay. So again, we just mentioned that there are two different types in Java: primitive type and reference type. A primitive type of variables directly stores the data for that variable type. Okay. Now, most of, most of the primitive types are integer, double, character. Or in Java, there's also some other primitive type like a long, Boolean. Um, so these are called primitive type. For example, if I say int number of students equals 20, so that means the number of students is, so Java can reserve the space in the memory and call the number of students. It's an int type, so once it's assigned 20, so then the value 20 is actually stored in that space. Reference type of variable can refer to the instance of a class and also as known as an object. Just let you know that, right? Okay. If X is a reference type, so then you're gonna Java gonna reserve the space, okay? Because it's a reference type, it's not gonna actually store the value. It's store the reference, okay? Or we, it's a memory address. Now this reference then refer to another memory location with the memory address. Okay, so the address stored here is the same as the address here. So you can actually point to this memory location, and then the actual value is for the object is stored here. Okay. Now for the next couple of slides, I will introduce a special type of classes. Okay, a very special type of classes. It's called a wrapper classes. Now, so just actually listen very carefully about these couple of slides because the wrapper classes are built-in reference types that argument the primitive type. Now, what does that mean? Sounds confusing, right? So now here's the deal. We know that the integer is a primitive type. So that means when Java create an integer variable x, Java reserve a space in the memory for x. When I assign a value 20 to x, then I actually store this value in this space, right? Now, when I create a reference type variable, so that means, like for example, like a bank account, or like a string. String is also a reference type. It's so I can say string B. So then the Java gonna reserve a space for A in the memory. Java gonna reserve a space in the memory for A, and then also Java gonna reserve a space in the memory for B. Okay. Now that space is fixed size. Okay. Now for the bank account, when I try to, call the constructor and create an actual bank account, so then I can actually use the syntax called so A equals new, and then I call the bank account constructor, right? So I can say I put the initial value $10 in there, and the bank owner is going to be Brady Chen. So that means I call one of the constructor in the bank account. So then I actually going to create an object. Okay, so that object stores the information of the bank account. For example, the balance is $10, right? Because when I call the constructor, I put then the $10 in the balance, and the account owner is Brady Chen. And then there's other like a methods is defined over here. So that's a big memory location, big memory space, which stores everything about this bank account A. Okay, so there's a special bank account. So when I actually called in constructor to create the actual object for the A, so then I'm gonna actually store this object in the memory location, and the Java gonna record this memory address. It's called a reference, and then store the address in over here. So if the memory address is 1000, then I store 1000 here. So that's basically means the bank account, A is a, a reference variable of bank account type, which points to the object which is located in the memory address 1000. Okay, just keep that in mind. And for the string B, if I actually say B equals John, so that means I actually assign a value John to the B. So then in this case, I'm going to reserve a memory location and put the value John over here, and then that location has a memory address, which is like 900. And then that memory address can be stored in the reference variable B. So the value for the B is actually 900, which is the memory address 900. So B actually point to this reference, right? Now this is not the case for primitive. Okay. Now Java provide something called wrapper classes. So the wrapper classes basically just create for certain type like integer, double. Sometimes people wants to use this primitive type as an object. Now, don't ask me why at this moment. I'm gonna explain later. Okay. So that means for every primitive type like integer, I'm going to create a corresponding class also called integer. That class is called a wrapper class. Okay. Now, for example, when I actually try to use a variable integer, so I can say an integer int x, okay, and I initialize the x value to 20. But sometimes I want to use the integer as an object, okay. So then I can Java defines something called a wrapper class. The wrapper class for the integer, for the primitive type integer, is called integer with capital I and integer y. So now x is integer type and it's int. So it's a primitive type. X is now y I also defined as an integer, but with that different keyword, different syntax. I use capital I and I type the whole integer, and then y is a reference variable. Oh, that's a primitive variable. Now, it sounds a little confusing, right? But don't worry. Now, at this moment, when I define an integer, y, I can actually even assign number to y. So I say 30 equals y. And this is perfectly fine. Okay. There's no actual error in this case. So you can define y as a reference variable, and I can use the y as the same as primitive type. So y is just like, it's almost like people are going to actually ask me, what's the difference between int and integer? What's the difference between int and integer? Okay. Now, when I use the integer or use the int, I can actually do this without any difficulty. So y 30 assigned to y. Okay. But just keep that in mind, y is not a primitive type. Now, how can you know y is not a primitive type? Okay. But when you do the actual assignment, it's still the same. I can even do this. So I declare integer type x and y, and I can define another integer reference type of z, and z equals 20. And then I can say y plus z assigned to x. So I can use the primitive type of integer and the reference type of integer interchangeably during the operation. Okay. But still, you should realize that the y and z are not primitive type. So that means in terms of memory allocation, so in the memory, when Java allocate X. Java reserve the space because X is an integer type. So, and then assign X assigned to 20, so 20 is over here. Now, when I declare integers Y and Z, Java gonna reserve a space of Y, reserve a space of Z. So these are integer type, capital I. So when I assign 30 to Y, I'm actually not copy the value 30 over here. No, I can actually reserve another space. Okay, and I put the value 30 here, and I actually record the reference, the memory address here. So which is actually like a 40, 400, for example. And then the 400 is the memory address. And I actually store 400 over here in Y. So Y actually pointed to the value 30. And the same thing with Z. Z is assigned 20, and then the reference here, and I store the reference over here in this position. So Z actually pointed to here. If that reference location is 500, then the value, the actual value stored in the Z is 500, but this 500 is a reference. So Z is actually pointed to the memory location 500, which stores the value 20. Okay. So in this case, Y and Z are the reference variables. You're still confused, right? So now I know I can declare X as a primitive type integer, and I declare Y as a reference type of integer. But I still can use this addition, and I can still use the assignment. Now, why you want to do this? Okay. Now, one difference you will find out is if I declare the integer type, say int x, y, and x equals 10, y equals 20. And then when I do the while loop, or I can say if I do the if loop, if I say x, I want to compare value of x and y. And then I can say do something. Now in this case, what is the value for this expression when I compare x and y? What's the condition for that?
True, false.
True or false? And what's the value? Is it true or false?
You're asking if it is true.
Yeah,
It is false, though.
it is false, right? Because x is 10, y is 20. Okay. So this is how we can actually compare two primitive type, x and y. Okay. Now if I declare integer a and a b, and I assign a equals 20, b equals 10, and if I say if a equals b, do something. What do you think the value of this?
Can you repeat the question?
If I actually do exactly the same, but except I declare a and a b as a reference type of integer. So that means I use a big integer, capital I integer a, b, and I assign 20 to a, assign b, 10 to b. And now if I say I want to compare a and a b, so a equals b, what do you think the value of this? That expression, is that expression true or false? Or what do you think the value going to be? Or anything else you can think of? I hope that A equals B will actually compare the value of A and B, right? If the value of A and the value of B are the same, then the expression should be true. If the value of A and B are different, then this expression should be false, right? What do you think? What Java gonna say? What's the reaction from Java? Actually, Java gonna actually give you the syntax error. Okay, this is not the right expression because A is not a primitive type. A is a reference type of integer. B is it's actually the wrapper class of integer. So it's a reference type of integer, and this is actually B. B is also reference variable of integer. So I cannot use this double equal to compare. For reference type, we are only allowed to use the methods provided by these reference. So this is not going to be the case. So if I want to compare the value of A and the value of B, I can use this. A dot equals B. Then do something. So now these two pieces of code are going to perform exactly the same thing. So if you declare x and y as a primitive type and assign value of x, assign value for y, and then I can use this double equal to compare these two primitive type. But if I declare as a wrap type, it's actually an integer of reference type of integer. And then even if I can use assignment 20 to assign to A, 10 assigned to B, when I say A equals B, I take it back. Java is not going to actually say there's an error, but the Java actually going to compare, but the result going to be very interesting. It's not the result that you expect it to be. Okay, why? Let me actually tell you this. Okay, let me actually just erase everything I just wrote. Okay, so let me. So if I say I declare integer, two reference type of integer, A and a B, and A equals 20, B equals 10. So what do you think? Let me see. B equals 20. A equals 20, B equals 20. So if A equals B, and I'm going to print out A is equals B. And if A is not equal to B, and I'm going to print out this. Now, what do you think? What's the output?
Uh, 20 equals 20.
Okay, so you're going to say this will be printed out, right?
Yes.
Okay, I will print the output going to be A equals B. So that's the output. Okay. Any other opinion? Now, at least that's the result. That's the result that we hope it's going to be, right? Because using the common sense, A is 20, B is 20, so I compare and B, oh, they're the same, so it's true. So I'm going to print this one out. Okay. Now, let me tell you the truth. The result is going to be most likely this. Okay. Why? Because A and B are reference variable. Okay. So when I declare A, Java going to reserve a memory allocation location A. When I declare B, Java going to reserve memory location B. Remember, this is reference, okay, not the primitive type. It's a reference type. So when I assign 20 to A, so I'm going to find the memory location and store the value 20. And so suppose the memory location over here is 1000. So the value of A in the reference type value, the reference value for A is 1000. So A actually pointed to that. So the 20 is the value that the A points to. Okay. When I assign 20 to B, Java gonna reserve a memory location that store the value B, and Java gonna record the memory actually address. So the memory address could be 1500. So B gonna actually store 1500. Okay. So B actually points to the object which has a value 20. So when we use A equals B, Java will actually compare the reference value. The reference value for A is 1000, which is pointed to, which is actually the address of the object. B, the reference value for B is 1500. So when A compares B, you actually compare 1000 and 1500. So they are not the same, right? They're not the same. So this can actually go to else and print out this. But what you hope, you actually hope that the Java gonna compare the values that the A and both A and B are pointing to. You want to compare these two values. But if we use this, it will only compare the reference value. You understand what I say? Now, if you want to compare these wrapper class object, so if you really want to compare 20 to 20, so you should use the methods, because A is defined as a class. That class is called integer class. So A is defined as class. A is not a primitive type. So A does not directly store the value. A actually stores the reference value, which is actually pointed to the object that the object stores the value 20. The object stores the value 20. Okay. So when you compare this, you compare with the reference value. Now, if you really want to write the correct code to compare the 20 and the 20, which are the objects that the both A and B are pointing to, if you want to compare these two values, then you should use the methods provided by the class integer. Okay, so that's the reason why we say it's different for the when you actually do the comparison. If you really want it to actually compare the value that the both A and B are pointing to. You should call A dot equals B. So equals is a variable, is a method defined in integer class. So when I call A dot equals, I actually call the class method. Okay, A is a reference variable. I call the class method and compare with another reference variable. So that means A equals B. This will compare the value that the A points to with the value that the B points to. So you now really compare 20 and 20. So you should use this. And then the output is going to be this string. Questions? I know it's kind of confusion, but you got to know the difference between the primitive type and the reference type. Reference types are basically the variable only stores the reference. The actual value is the object which stores in the object that the reference value points to. Okay. Now, so this is something you need to actually understand. I will give you a couple of examples, and I will ask this question on the on the Blackboard, the discussion forum. So I hope that you can look at this various different scenario, because it's too much to talk all the possible case in class. But I will actually put together these, and you probably need to look at the discussion value. Now each team, I want each team to look at the discussion forum today. So I'm gonna post this information today, so you can hopefully like this afternoon. So you can actually look at this one and you discuss this one and give me the answer in the discussion forum. Okay. So I'm gonna move forward. So the wrapper class. So for example, like an integer, that's a primitive type, and the corresponding wrapper class is integer. And if I have a double, then the corresponding wrapper class is called a double with the capital D. Okay. If you have another class like a long, lowercase, and then the wrapper class is going to be long. So these are the wrapper class. Now I still haven't talked about why people want to use wrapper classes, because looks like a primitive is kind of easy to deal with, but wrapper class, it's more complicated, because wrapper class, the primitive type, you just actually declare a variable and store the value in the variable. That's it. But the wrapper class is declared as a class. So the value for this class is something, but they also define many methods, okay, to use. Okay. Now one of the approaches called boxing and auto boxing and unboxing. So this auto boxing and unboxing allows the people to use the primitive type integer and the wrapper class integer interchangeably. But they're still not the same. Just keep that in mind. It just makes it easier for people to use them. For example, so you can just say, I declare int x and declare integer y, and then I can say x equals 20, and I can assign y equals x. So I can do the assignment. So So y has a value 20, but keep that in mind. Y is a reference type. Okay, you cannot directly compare x and y. You cannot do that. Okay. So, and in the meantime, I can do the other way around. So I can, you know, so you can actually use x and y interchangeably when we actually deal with the addition, multiplication, and assignments. But when we, in terms of comparison, when you compare two values, the primitive type can use this. And primitive type can also use factorial equal, not equal. But the wrapper class, you cannot. You have to use a method called equals. Okay. So that's the differences. That's the only difference for now. And later on, we're going to talk about what is the reason people want to define a wrapper class. Okay. Also, so if you want to convert between the wrapper class value and the primitive type, you can use the method defined in the wrapper class. For example, int value, double value, long value. These are the methods that are defined in the wrapper class. Okay. For example, num1 is a wrapper class, right? It's a capital IN. And these are also wrapper class double with a capital D. And this is also wrapper class double. Okay. Okay. So now, if you can actually call number 2 dot int value. So this is going to actually convert this wrapper class value into an integer value. So this is going to return 6.7. It's converted to the integer, so you can actually get rid of the fractional part. So you're going to return the value 6. Now, number 1 dot double value. So number 1 is an integer type for the wrapper class of integer type. And then if I say number 1 double value, that means I'm going to convert this integer 14 to a double value, which is 14.0. Okay. So this is actually allows you to use the method to convert. Now, if you want to actually convert to the primitive type of the same primitive type of the same type, then you just use the inbox, unbox, and autobox. Okay. But if you want to change the type from integer to double, from double to integer, you can actually use the methods. Okay. Now, one particular actually wrapper class we have used is the string class. Remember when we say, when we declare a string x, string is not primitive type, right? So we can actually assign a value x equals I am a computer science student. It's a long string. Okay. So then when you declare a string type, Java just reserve a space. X is a string, so it's a reference type. So, and then when you assign a value, and then Java can reserve the space and store I am a computer science student. Okay. And then store in the memory location and record the reference for this object. This is the object. And the reference is, say, 1000. So Java stores 1000. This is the memory address. It's pointed to this. So X pointed to the object object which stores the value. I am a computer science student. So string is a reference type. So that's the reason why when I compare two string, I cannot compare the string. Say, if I declare string X and a string Y, I cannot use X. I cannot use the string X equals Y. Okay. While this will give you the comparison, but it's not really compare the actual string. It's actually comparing. It will compare whether X and Y has the same reference value. Okay. Now, X equals Y. If both X and Y are string, X equals Y returns true only if both X and Y has the same reference value, right? So that means only if both X and Y has the same reference value. So that means both X and Y are pointing to the same object. And then X and Y equals Y going to return true. Okay. Only if X and Y points to the same object, pointed to the same object. Okay. Now, so this, let me actually tell you two different scenarios. So say string X, Y. Okay. Now X equals John. Y equals John. What do you think the value? Is this true or not? True or false?
It's true.
It's true. It's false. Okay. Let me tell you why. When string, I reserve a space X, reserve a space Y. And then when I assign John to X, so I create the object and which stores the value John. And then X, going to record the reference. Okay. When I actually create the Y and then I create the John, and then I create the John, an object. And this object, John and John, are actually different objects. So they're located in different memory location. This memory location is 1500. And then I store 1500 in there. When I compare X and Y, I compare 1000 and 1500. That's false. Now I just take an example, 1000 and 1500. The actual reference value is unknown because Java actually hide this reference value. But I know reference values are different because when I actually assign John to X, assign John to Y, so I create a different object. And these different objects both store the value John. But the reference value for these these two objects are different. So X and Y, if I compare directly, is not the same. So if I actually say X dot equals Y, this is going to give you true. Any questions? Got this?
Yeah, I do have one question.
Yeah.
So if there is a capital string or capital integer, that's how you know that X and Y are references?
Yeah. Yeah, but the string is kind of different. There's no lowercase string. It's just a capital string. But a string is a reference class or reference variable. Now, suppose I do this. I say string X, Y, and X equals John, and Y equals X. Now, what is this expression? True or false? This is true. Why? Because when I actually do X equals John, so then I reserve a space for John, and I assign the value John to the object. And then I actually X as stores the reference for the object, right? But when I do Y equals X, so actually what I do is I copy the reference value of X to Y. So I actually copy 1000 to here. So I copy these reference value. So when the assignment does not assign the assignment basically only copy the reference of X to Y. So then in this case, so Y and X has the same reference value. So Y and X actually pointed to the same object. So in this case, if you want to print the value, so in this case, if you want to print X and print Y, you're both gonna print John. But you realize Y and X are pointed to a different John because they're different object. But in this case, when I create the John and assign to X, and when I actually do the assignment X to Y equals X, so the reference value of Y, X assigned to reference value of Y, so Y, in this case, both X and Y point to the same John. So when I actually print X and print Y, they're both gonna print John, and these are the same John, not the different John. So when I say X equals Y, now the value of X in this case is 1000, and the value of Y is 1000 because when you use the comparison like a double equal, then you have the same reference value. So then they're the truth. And also, what is X equals Y? This is also true, right? Because X and Y points to the same object. Of course, they're true. Now, this case, this is true because X and Y, they point to a different object, but the value in the object are the same. Still confused? So
It's just a lot to take in.
yeah, I think this is actually kind of confusing topic, but you got to know the difference between the primitive type and the reference type. And for the reference type, when you do the assignment, you actually not copy the object, but you copy the reference value. So that means, so when Y equals X, that means Y gets the same reference value as X. So y actually y and x and y has the same reference value. So they point to the same object. Okay. That's very important. Okay. Now, next time we're going to talk about the array list, and then we're going to talk about why we have a primitive type integer and primitive type double, why we want to create a reference, the wrapper class, the reference type of integer. Because reference type of integer is very expensive because it's the primitive type only stores the value. The reference type, you stores the value and you also store various different methods to process this value. Now, one of the reasons is with the reference type of integer, you can create an array which is very flexible. Remember, when we declare array, say integer array x and then new integer. Now, each time when you define an array, int, square bracket x is an array of 20 variable. So Java can reserve, a 20 space. Each is an integer value. So that's x0, x1, and x19, right? Now, when you declare the array, if we use the primitive type of integer, it's not really flexible because you have to tell people how much space you need to have, how many elements you will define for this array. You cannot define an array which is actually has a variable size. So the array size cannot change. It's always 20. Now, if we want to use the variable a different size, then you have to actually define a fixed number of array, like array of 100 variable, and then you only use like a 20 elements or 30 elements, but you cannot use the number of elements which is more than 100, because once you declare it's 20, then that's an array of 20. But with the wrap class, like a reference type of integer, integer with capital I, then you can declare an array of variable sizes. You can change the size of the array. Okay, so that's something we're going to talk about later. But I will post something on the discussion forum. So please, each team, hopefully you still remember the team member. If you can, then check the announcement in the Blackboard and find out who is your team member. So you can discuss about the question I'm going to post on the Blackboard. Okay. So I think that's pretty much all for today.
Have a good one.
Okay. So have a good one.
Thank you very much, Professor.